In virtual circuit identifier, the identifier it is actually used for the data transfer. Okay, this method we call it as a virtual circuit identifier. Okay, we label it as a VCI. Okay, the VCI it like basically it won't works based on the global address. Okay, it will be work only the local address. Okay, in that switch case, see you look at this switch here. uh, the data or the identifier it contains the frame between the two switches. Okay, so this we call it as a frames, means the frames it contains the data it is going to contain in the format of frames. Because why? Because our virtual circuit identifier it is totally depends on the our datagram circuit network. In the datagram circuit network, okay, it contains the data link layer. Okay, our data link layer, our data link layer it contains the data based on the frame. So that here our VCI means that our virtual circuit identifier it is going to contain our both our switches and frames. See, this is the data. Okay, this is the data along with the our local address. Okay, our VCI identifier it is going to contain a data means frames and local address. Okay, based on that it is going to send the with the help of switch to finally that data it is going to reach to our destination. This is what our virtual circuit identifier. The next one is, then what is it? This is the virtual circuit delay timing diagram. Yes, our delay timing diagram here, here I have taken as a as the input or A as the sender and B as the receiver. The sender and receiver actually it has to be do the transaction with the help of switches. Here I have taken two switches or two devices, two switches devices. Okay, our virtual circuit diagram it is going to contain three phases function, that is one is setup function and another one is straight down function and delay function. Yes, our setup function it is going to tells the establish it between the two parties, means here two parties is nothing but sender and receiver. Okay, it is going to make the connections between sender and receiver. Okay, once the connections will be happen, after that it is going to make the transaction, means after that it is going to transfer the data that particular destination. This method we call it as a data transfer connection function. See, once the data transmission is over, okay, after that it is going to take about the trade function. In that trade function, what will happen means, okay, here the both the parties are there. Okay, either sender or receiver. Okay, once one party it is going to it is going to cut the connection, means it is going to complete the transaction, the entire resources it is going to be released. Means other hand side, if either a sender or receiver it is going to any one of the any one of side it is going to complete the transaction. So our switches our switches it is going to release the particular resources. So this is the method we call it as a trade on function. In this trade on function, data rate connection function, setup function, totally it is going to take the some small amount of time. Okay, that we call it as a total delay. See, the total delay it is going to manage the three phases function. Means these three phases time. Okay, how much time taken they have taken between the send or receiving the particular data in that particular two parties. Okay, that everything it will be take care our total delay. The next one is we are talk about error detection and correction and data control. Okay, our error detection and correction means the name itself only we got to know what is the error detection, means how we are going to detect the error, and once we detect the error how we are going to again that error how we can going to correct that particular error, means what and all technology or what and all method we are going to follow in this follow how we can going to correct that particular error. See here, the error detection and correction, the data can be corrupted during the transmission. Means like when the error detection and correction will be happens, means the data can be corrupted during the transmission time. Okay, in that is one of the time also we got the error detection or correction problem. After that, if the communication reliable, means where if the communication will be takes place during that time also our error must be detected or corrected. And then we have two types of errors. Okay, the first will be error single bit, means single bit error, and second one is burst error. Okay, we have two method that one is the single bit error and another one is the burst bit error. See, what is the single bit error now? Mean the single bit error is nothing but it is going to tell us about only one bit of a given data unit. It is going to change from 1 to 0 and 0 to 1, means high to low and low to high. Okay, so this method we call it as a single bit error. See, can you look at the diagram here? This is what our single bit error. See, have taken two two number format. See, I have taken sender side, okay, one format, number format, and receiver side another number format. Here the sender, it is going to change the zeroth bit, means 0 it is going to change at the receiver side. It is going to change as a 1. See, this method I am going to call it as a single bit error. Otherwise, see, this 0 it may be going to change at the 1 at the receiver side. So this method we call it as a single bit error. The next one is burst bit error, means the burst error means two or more. In that single means only one bit it is going to replace with the, either if it is 0, okay, we are going to replace with the 1. Okay, if it is 1, we are going to replace with the 0 at the receiver side. Okay, that method we call it as a single bit error. But burst error means here it contains two or more bits in the data, okay, data unit, and that data unit it is going to change from 1 to 0 and 0 to 1. See, you look at this diagram. See, this is what the sender side having the number format, and this is the receiver side having the number format. Okay, so the length of the means the length of the bit here, it contains the 5 bits. See, 5 bit here, 1 2 3 4 5. Okay, within that 5 bit I am going to replace the 0 into 1 and 1 into 0. See, the sender, okay, it is going to replace 0 from sender to receiver side. Okay, see here the 0 it is going to replace with the 1 at the receiver side, and here also 0 is going to replace with the 1, and here also 0 is going to replace with the 1. So this method means here two or more numbers we are going to replace at a time. Okay, this method we call it as a burst error. Then burst error does not necessarily, okay, mean that errors occur in the consecutive bits. Yes, see, the error will be occurs for consecutive bits. The length of the burst error measured from the first corrupted bit to the last corrupted bit. The next one is redundancy. Yes, what is the redundancy? Yeah, in that spread spectrum also we are used the redundancy because of we have to elaborate our bandwidth. So because of that only we are using that spread spectrum spread spectrum topic, we are using the redundancy. But here in the error detection and correction we are using the redundancy because of to detect our error correct if to detect the errors and correct the errors. Okay, because of that we are going to use the redundancy here. Okay, then we need to send the redundant bits with the data. The redundant bits are added by the sender and removed by the receiver. Yes, we have to add the that particular bit redundance bit at the sender side or and the receiver side also. The error detection uses the concept of redundancy, which means adding the extra bit of the detecting errors at the destination side. So then this is the like a